Students, we are given this question, integral 0 to pi x divided by 1 positive sine x times dx. Now, I would be rewriting this as integral 0 to pi x of 1 over 1 positive sine x times dx. Now, this is similar to integral 0 to a x times f of x times dx, which is equal to a over 2 integral 0 to a f of x times dx, provided f of a negative x is equal to f of x. So the condition that has to be satisfied for integral 0 to a x times f of x dx to be equal to a over 2 integral 0 to a f of x dx is that f of a negative x should be equal to f of x. So if we are going to be taking f of x to be equal to 1 over 1 positive sine x, then we have to show that f of a negative x, so in this case the a is pi, negative x is equal to f of x. So since I have taken f of x to be as 1 over 1 positive sine x, this is going to be 1 over 1 positive sine of pi negative x. Now we know that sine of pi negative x is equal to sine x. In the previous example I have shown you that. So this means I would now have 1 over 1 positive sine x, which is nothing but f of x. So clearly f of pi negative x is equal to f of x. So hence what happens now? Hence the integral 0 to pi x of 1 over 1 positive sine x times dx can now be rewritten as our a is pi divided by 2 integral 0 to pi. Instead of x, I'm going to be writing the function. The function is 1 over 1 positive sine x times dx. Now, in the previous example, I have shown you an important result, which is integral 0 to pi g of sine x times dx is equal to 2 times integral 0 to pi over 2 g of sine x times dx. This is an important result we got from the previous example. Now, because of this result, I can rewrite, the given integral as 2 times pi over 2 integral 0 to pi over 2 1 divided by 1 positive sine x times dx. So this would give us pi integral 0 to pi over 2 1 over 1 positive sine x times dx. Now there is another important result. Also, we know that integral 0 to a f of x dx is equal to integral 0 to a f of a negative x dx. So this is another property that we would be using. Because of this property, the integral can be rewritten as pi times integral 0 to pi over 2 1 over 1 positive sine of pi over 2 negative x times dx. Now, sine of pi over 2 negative x. Now, if I were to show you that sine of pi over 2 negative x, this is nothing but sine pi over 2 times cos x negative cos pi over 2 times sine x. Now, clearly this is equal to sine pi over 2 is 1 multiplied with cos x. This is going to get cancelled because cos pi over 2 is 0. So this is going to be equal to cos x. Okay, this is another important result we would be using here. So this is equal to pi times integral 0 to pi over 2, 1 divided by 1 positive cos x times dx. Now, there is another result that we have to know, which is 1 positive cos 2x divided by 2 is equal to cos squared x. This is an important result. Now, we have 1 positive cos x here. So, if I were to take, say, 2x is equal to some t, then x will be equal to t divided by 2. So, therefore, this result can be rewritten as 1 positive cos t divided by 2 is equal to cos squared t over 2. But since we only need 1 positive cos x, so we can rewrite this as 1 positive cos t is equal to 2 times cos squared t, of course, with the 2 in the denominator. So we would be using this result to this integrand. So this is now rewritten as pi times integral 0 to pi over 2. In the place of 1 positive cos x, I would be rewriting it as 2 times cos squared x over 2. Of course, we have 1 in the numerator that has to be product multiplied with the differential operator dx. Now, we also know that 1 over cos x is equal to secant x. So this implies 1 divided by cos squared x is equal to secant squared x. This also implies that 1 over cos squared x over 2 is equal to secant squared x over 2. So I would be using all of this in this. So this is rewritten as pi over 2 integral 0 to pi over 2. 1 over cos squared x over 2 is secant squared x over 2 times dx. Now, we know that integral secant squared x dx is equal to tan x positive c. Now, because we know this result, this is going to be equal to pi over 2 tan x over 2, the limits are 0 to pi over 2. Because of this x over 2, we would have 2 multiplied there. Now, this is rewritten as pi times tan of x over 2, limits are 0 to pi over 2. Now, applying the limits, substitute the first limit, which is tan of pi over 2 divided by 2 negative tan of 0 divided by 2. So we got something like this. Now this is rewritten as pi times tan of pi over 2 divided by 2 is going to be pi over 4. Now this is going to be cancelled because of tan 0. So this is rewritten pi times tan 45 is 1, which is equal to pi. So this is the final answer